Good evening, sir.
Hello everyone. Can you hear me? All of you?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Should we wait for others? Let's wait for 1 minute. Others will join. All right.
Hello.
Fine. So let us start today's session on problem solving of gravitation. Okay. So there won't be any theory discussion directly while discussing the questions. There can be some relevant theory discussion. Okay, so that is the idea, and I have taken questions. Uh, some of the questions are which you might have seen before, but majority of them are little tricky in nature. So if you are not able to solve many of them, doesn't matter. Okay, because I have ensured that many questions you should not be able to solve, so that we learn from this session. Okay. So solve this question. You can DM your answers. Okay, shall we discuss now or should I wait? You can speak up. You don't need to be on mute.
Yes, I think we can discuss this.
Okay. See, there is a satellite. Now the satellite is not kept on Earth. So satellite's angular velocity can be different from the Earth's angular velocity. So Earth is also rotating. So we need to account for that. All right. So it is revolving in equatorial plane. So Earth also rotates like that, wherein this is the equatorial plane and Earth rotates like this. And Earth rotates again from west to east direction. All right. So the omega of the Earth is 2 pi by uh, we can write in hours omega 2 pi by 24 hours, 2 pi by time period, right? This is of the Earth, and omega of the satellite is uh, 2 pi by 8. All right. Now we need to basically see with respect to Earth, right? Because it is observed vertically overhead a longitude. So basically, there's a person standing on the Earth who is observing the satellite. Now, that person is rotating with the Earth. So the person is looking at the relative angular velocity of the satellite. So the relative angular velocity of the satellite, because if let us say both the angular velocities are equal, then the person won't see the satellite moving at all. It become like a geostationary satellite. Okay, so that is why relative angular velocity has to be seen. So 2 pi by 8 minus 2 pi by 24, that you equate to 2 pi by time period. Time period as in how much time it takes to revolve. Right? So from here, you'll get the answer. Are we getting 12, everybody?
Yes, sir.
Okay. So, one very important thing that we sometimes ignore is that the Earth is rotating. All right. So, once in a while, that fact is used. And time period of rotation is 24 hours. So, omega you can easily find for the Earth. Do this. Yeah, these initial questions, everybody should be getting it as a warm up exercise. We can, I think many of you have already answered. Shall I wait for others? Anybody? Okay. Now, one very important relation which is used so many times is t square is proportional to r cube, right? So, this is for the planet, for the satellite. Yeah, somebody is saying something. Okay, right. So, whenever appropriate, we should be using this law. So T1 by T2, because it's like the question is framed in such a way that it's a comparison of the time period of revolution is equal to R divided by 4R cube, right? So T1 by T2 is 1 by 8, right? 4 is 2 square, so square get cancelled, so it become 2 cube. So 1 by 8. So time period of this satellite B, if it is 8 hours, then for A it is 1 hour. That way you can think. Now in 1 quarter year is 8 divided by 4, it becomes 2 hours. How many revolution A will make? 1 hour it makes 1 full revolution. So in 2 hour it will make 2 full revolutions. So answer is 2. Okay, so you may have your own way of reasoning it, but this is how you do it. Okay, any doubts, anybody? Nothing?
No, sir, no doubts.
Okay, good. One more. This is also a straightforward question. Do it. If you do gravitation properly, then electrostatics, laws of motion, work by energy, many chapters automatically are getting revised. So don't think that it is only gravitation you are studying. Soon you'll realize that many concepts from different chapters are utilized. Only one person has answered till now. What else? Okay. 3, 4. 4 people have answered, and all 4 of you got it correct. That's good to see. I'll do it. All right. See, it is somewhat similar to the previous question. But in previous question, if you see, both the planets are revolving around the same center point, which is Sun. Okay. But here, the Sun is orbiting, and the Earth is orbiting Sun. So basically, there are two center points of revolution. So you cannot use T square is proportional to R cube like that here, because like two different scenarios. But uh, there is an expression between, because you can see the options also, and the question is framed in such a way that it is about time period and the radius of the revolution. So we need to basically get the exact expression wherein, yeah, wherein there is an equal to sign, because we can't use proportional to, because proportionality constant for both the scenarios will be different, as there one is revolving around Milky Way and one is revolving around the sun. So, I mean, do you guys remember that exact expression or not? Or you tend to derive it?
The time period one for orbit,
T square is equal to what into R
I
cube?
derived it.
You derived it. Okay. Yeah, even I would have derived it. I don't even remember people's name, forget about the formulas. So this is the instead of V square, I'll use omega square, m omega square R, right? So m and m get cancelled. So what you can say, omega square is equal to, in fact,
4 pi square by t square, right?
thank you. So this is 4 pi square t square r. So then it becomes r cube is equal to gm by 4 pi square t square, right? So this is where, this m is coming. So in the first sentence where it is revolving on the galaxy, this is the mass of the galaxy. And this is capital T and this is capital R. And in the second situation, instead of capital R, it is small r. And this is mass of the sun now. And this is small t square. So, since there is an equal to sign, you don't need to assume that proportionality constant should be equal. So now you can divide it and get a ratio of mass of galaxy with mass of sun. Okay, in both the scenarios, we are using t square and r cube relation only. But here, you can use just proportionality and divide so that constant get cancelled. But here, there are two different revolutions. So proportionality constants are not same. So you need to get an equal to sign. So this is how you solve it, and probably A is the answer because majority of you have said that. Not 100% sure, but this is how you do it. Okay. Shall I go forward?
Yes, sir.
Okay. Now get ready. We'll just go one level up. Okay. And do it. Maybe you should be very, very, I can say, honest. And if you're not getting, you're not getting. At least you learn something. But if you uh, get the answer from somewhere somehow, then you'll not learn also. Okay, so just focus on the learning. Do this. Just draw the free body diagram, show the forces, and the horizontal force should be less than or equal to mu time normal reaction. That's all you have to use. Intensity of gravitational field is nothing but acceleration due to gravity. Force divided by mass is acceleration due to gravity only. That is intensity. I'll do it.
One second. Yes, I can do.
Okay, some of you got some answer. Okay, let's do it then. So assume that this angle is theta. Okay, let me take it horizontal only like that. Yeah, this angle is theta. So there is this B is here. It is revolving, so B is here. Okay, so this is the gravitation force between this mass and B, which is mass capital M. Then it has mg over here. It has normal reaction. Okay, and you can assume a plane which passes through all these forces, and this is your friction force. Do you all understand any doubts in free body diagram?
No, sir.
Nothing. Okay. Now, you have vertically, you can say n plus fg sine theta minus mg is equal to 0, right? So n is equal to mg minus gravitational force sine theta, and friction force should be um, less than or equal to mu time normal reaction, right? And horizontally, there is the normal force. Horizontally, there is I can write like this: F minus Fg cos theta is horizontal, right? This should be equal to 0. So friction force should be equal to Fg cos theta, and friction force is this Fg cos theta should be less than or equal to mu time normal reaction. So g minus Fg cos theta. So
Sin theta, sir.
Sine theta, sorry. Sine theta. Is this fine till now? The range of
Yes, sir. I reached this equation too. I didn't know what to do after this.
friction between so that it remains motionless. Okay. So what is the value of Fg? Fg is Gmm by R square. Gmm by R square cos theta less than or equal to mu mg plus this. So we need to basically see theta is a variable. We need to get rid of it. Now,
So value of theta is there in the diagram.
what?
The pi by 2 minus theta, we can write it as sine of pi by 2 minus theta is.
No. Plane of a circle perpendicular. कुछ miss हो रहा है क्या? Anything is missing here? Friction is equal to Fg cos theta.
No, sir. I got the same equation. I
So
tried making it as an equation in terms of mu and then finding its like minimum value or something so that mu can be greater than that, but that didn't work.
it should
Like
work.
the derivative was very weird.
You don't need to
Should
take
work.
derivative everywhere. Keep quiet 1 second. This. Now we need to get rid of theta. So see, theta is a variable. So can anybody tell me what is the maximum value of this? What is the maximum value of this?
Under root 1 plus mu square.
Under root 1 plus mu square. So the maximum value of this should be less than mu mg. All of you agree or not? Huh?
Yeah.
So Gmm by R square, maximum value is 1 plus mu square, should be less than or equal to mu mg. I'm gone. So this will get you the value of mu. Is it clear now?
Yes, sir.
Yes, sir.
Has anybody done like this? Anyone? Okay. All right. Fine. So as far as I know, the answer is C. If you simplify, you should get C. Let me check. Final answer C. Final answer is C. Correct. Okay, shall I move ahead? See, this is where, I have seen many Olympiad questions in which they get something like this, cos theta plus some constant time sine theta, and you have to take the maximum value of that. So that is how it should click to you as well. Okay, it's not that you can substitute the value of theta to be something. Uh, Basically, you can use calculus or whatever you want to, because this is the only thing that is changing. So you need to maximize this. You can maximize using trigonometry as well. Fine. Shall I go to next? Anybody has any doubts? Any doubts? Anybody? Okay. Go to next. This one. You need to think freely. Then only you will be able to do these kind of stuffs. You can type in your final answer. I'm giving you maybe 4 or 5 minutes. I should not disturb you. So 4 or 5 minutes I'm giving you. Collinear means that they are all rotating together like a stick. You consider a straight line, and the entire straight line is rotating. Okay, and the both the stars and ships are on that straight line. Checking whether orbit is stable or not is beyond our scope. So ignore the second statement. Actually, it is not stable. Shall we? I hope some of you are in middle of this thing. Any physics question, any question starts with a diagram. proper well-labeled diagram is half the question done. Should I write the final answer? Final answer I have M1 by M2 plus R2. This is the final answer. Anybody fighting still to get the answer?
So,
About to?
yes.
Swani, you got the answer? Got some answer?
No, sir.
Vivan,
No, sir.
what is stopping you? You don't know from where to start? Is that the issue?
No, I kind of did find a place to start. The entire system, if it's collinear, would have the same angular velocity about some point, right?
What is that point?
I tried to find that point. That's what I'm not getting.
Are you sure? I mean, can anybody help? What could be that point about which entire thing is rotating? What do you think? Pune, I'm in a class.
So probably the central point of the binary star system.
Exactly, center of mass. So everything you look at with respect to center of mass. That is a good starting point. And then, haven't I told you in 11th and 12th that if anything is rotating in a circle, what equation you should write first? What is that first equation?
Intermediate first one.
Anything rotating in a circle, you have to write force toward the center is m omega square into radius. That is the first equation you should write. And that's all you have to do in this question. And what is that center? Center for all three is what? Center of mass. Should I do it now? We just write the equations. Acha, can you do one thing? Draw the diagram, all of you. Represent all these values and then I will just write down the equations. Do it quick.
Sir, I have a doubt in the diagram.
Diagram bana do pehle. Let me
No, like
also draw the diagram and then we'll discuss. Right now, what do you understand? Draw it. Okay, so I hope all of you have drawn it. So this is that line. This is one star. This is the other star. One is M1 and M2. Now there is a spaceship also. Now spaceship mass is so little compared to star that we can assume center of mass doesn't shift anywhere. So center of mass is, let's say, here. This is our center of mass. Okay, distance spaceship from the star is R1 and R2. So this is your R1. This is your R2. But the revolution is happening with from no at the center is center of mass. So R1 and R2, they are not the distance from center of mass. So you need to assume something. So you can say this is A, this is B. You can say C also, but you don't need distance of center mass from the spaceship, because that you can get now. B minus R1, that is. Okay. So yeah, tell me, what is the issue with the diagram?
Sir, how are you so sure that the spaceship has to be between the stars and not someplace out?
How what?
Like, why does it have to be between the stars?
That is the condition. They are collinear.
But they can be collinear if the spaceship is not in between the stars also, right?
How it can be collinear? If it is here, how will you make a straight line connecting all?
Like on the same line, but on one of the sides. So one of the
Oh,
stars is on
okay,
the same side.
okay.
Yeah,
Yeah.
but then it wouldn't be much of a spaceship, would it, if it can't see one of the stars?
No. Let it be that side also. Let it be. It doesn't matter. If you keep it here, okay, and then rotate it, that is also fine. But then, since in the question it is not specified whether the spaceship is in between or outside, so clearly it doesn't matter. But then you have to solve. And if you have to solve, then you have to assume one of the two scenarios. And whatever scenario you assume, the answer should come out to be same. Right? So you can't get confused for that, because it doesn't depend on it since it is not given. Is it clear, Aditya?
Ah, yes, sir.
So I hope you understand how it is revolving, everybody. This binary star revolves around center of mass like this. Okay. Whereas this M1 can revolve about center of mass in a bigger circle like this. So both of them are revolving around the center of mass as a center. Now I have to erase this.
Excuse me, sir.
बोल
I thought, why can't the satellite be at the center of mass itself?
That becomes a specific scenario. That is not a you can. हाँ ठीक है, रख ले. Keep it. Answer won't change still.
Okay, sir.
But I try to solve like this. Okay, fine. If the spaceship is at the center of mass, then it is always collinear, isn't it? It'll be always collinear. Then uh, whatever is the value of M1 and M2, it will be collinear only, because center of mass doesn't move. And if one goes like this, then M1 is here, M2 is there. Yeah, it will be always collinear. Anyways, let's solve for this scenario. So first of all, for this center of mass, for this to be center of mass, all of you agree that moment of masses should be equal? This equation, all of you know this or not?
Yes, Yes, sir.
Okay. Then the constraint relation A plus B should be equal to R1 plus R2. This is second. So using these two, you can get either A or B in terms of R1 and R2, right? So that is one. Then let us say angular velocity is omega. This is omega. This is omega. So the force on M2, what is the force on M2? G M1 M2 divided by R1 plus R2 whole square. This is the force towards the center of mass, right? I hope all of you agree. I am ignoring the gravitational pull by the spaceship on the star. It is negligible. This should be equal to M2 omega square into what? What should I write? Anyone?
Sir,
What
you're
should
doing this for M2, right? So it's distance from the center of mass.
So what is that? That is what
A.
I'm A. Now somebody else will answer the next one. So for the M1, we can write G M1 M2 by, see, for M1 we should not write because it becomes a redundant equation. You can see here. If you write for M1, it will become like this: M1 omega square B, right? So if you combine 3 and 4, it becomes 1. So it gives you redundant equation. Equate right hand side of 3 and 4, it becomes redundant. So we don't write redundant equation unnecessarily. But now we will write the equation for the spaceship. Can you all write that equation? All of you, please write. Let me know once you're done.
Done, sir.
Others, are you guys done? For the spaceship, spaceship is getting pulled this way and this way. So towards the center of mass force you have to take. That is G M2, M is a mass of spaceship divided by, what is the distance? R2 square minus G M1 M by R1 square. This should be equal to M omega square. Distance from the center of mass is what? For the spaceship. What should I write here?
B minus R1.
B minus R1. I told you, let somebody else tell. Anyways. So these are the 4 equations. You have to play with them and get the answer M1 divided by M2. Okay. So mathematically, it appears that it is not an easy equation to solve, but I think you should be able to. These 3 and 4, there is B and A, right? So you can write A as R1 plus R2 minus B here, and then substitute B as, you can get B in terms of R1 and R2 by writing this A as M1 by M2 times B, plus B is equal to R1 plus R2. So you can get B in terms of R1, R2, substitute here. A you write R1 plus R2 minus B, substitute here also, and then just play with it to get the answer. Okay. I'll move on to the next question. Right? Okay. Are you finding it tough?
Interesting is a better word, sir.
What?
mean, it's more interesting than it is tough.
Okay, should I give you much more interesting ones?
I
Everybody?
don't think so, sir. I think this is enough for today.
I have these kinds only. Do this. I'm giving you another 5 minutes to solve. What is that first thought that comes in mind when you read this question in order to how to solve it? First step.
So may I?
हाँ बोल.
Escape velocity will be different for every particle depending on how far away from the planet it is, correct?
So you're just taking the escape velocity clue from here and trying to fit in how do I solve with respect to escape velocity, using that as a starting point.
Basically, I'm trying to find that distance from the planet
Hmm.
below which every particle gets captured into orbit.
That velocity below which every particle get captured.
That distance from the planet, because all of them have the same velocity.
Uh-huh.
There will be some distance from the planet at which that velocity will be sufficient to escape orbit completely and leave the planet, not get captured. Anything below that will get captured. So if I can find that value of r, then that gives me the thickness. I already have the length and density.
Okay, great. So
I
what
got an
Vivan
answer
is
as well.
saying, what Vivan is saying that this is the cloud, right? This is the cloud. So he's trying to find out how far the particle can be in order for it to get captured by the planet, right? That's what you're saying. So how will you basically get that, how far it is? What is that limiting condition for which it should get captured? You understand my question?
Yes, sir.
How do you get that this is the farthest away the particle will be for it to get captured with the planet? कैसे आएगा वो?
So, should the velocity in the direction of the planet be greater than the escape velocity?
velocity in the direction of the planet. Acha, component, this component.
Yes,
But
sir.
it is coming towards the planet, right? So whether it is greater or not, it will fall on the planet. It's not going away. If it is going away, then escape velocity comes in picture. Think more.
The point at which escape velocity becomes zero of a particle.
Escape velocity becomes zero is infinite. So that is the entire cloud will get captured then. Don't get fixated on escape velocity. That is what I would say, because particles are moving towards the planet. It's not that it is going away. I mean, I know even when I was solving before the session, I was reading too much on this escape velocity thing, but it's not about escape velocity. It is about something else.
So
How
is
the
it about conserving momentum?
how the particles will come towards the planet? How do you think they will travel? They will get attracted by the gravitational pull, right? Oh. So these so straight away get into like this. Suppose this particle, how this particle will go to the planet? It travels like this and falls like that, isn't it? It falls like that. Now, can I say that all the particles falling on the planet has the same velocity? Is it true or not?
Yes, sir.
You can conserve energy, and you can see that initially they are moving with what velocity? V naught. And kinetic plus potential is constant, so you know that just before reaching the planet, every particle's velocity will be equal. So it's not about that some particle will have a different velocity compared to other, but still some particles will miss the planet. Why? Why they will miss the planet? Because they will go like this instead of falling on the planet. They will get attracted by the planet, so that is why they get deviated, but it doesn't fall on the planet. Just imagine a particle is just falling on the planet. Then what will happen to the particle? Particle go like this and tangentially touches the planet like this. Do you all agree? Not getting it? If let us say this is the planet, okay? This is the planet. So this particle, the limiting case, the particle will travel like this and will just go tangentially like this and falls on the planet. Do you all agree? The particle
Yes, sir.
just above the particle will miss the planet and will go like this. Agree all of you? Can you type in or speak?
Yes, sir.
Right? So the limiting condition is that, what is the condition? That the particle, when it reaches the planet, its velocity is tangential. That is the limiting condition. Now, can anybody guess what could be that physical concept we should be using to capture how far the particle should be from here? What law can we use for that situation? Because this distance, like what Vivan said, if you get this distance, then I can just imagine a circular cross section here. Then all the particles have the same scenario, and I need to just get volume of the cylinder multiply with the density. I'll get the answer, right? So how to connect this velocity, this distance, and this velocity, and some distance? Which concept?
Projectile motion.
Law. Which law? law?
We can conserve angular momentum.
Angular momentum. You have to conserve angular momentum. About what? About this point. About this point, the particle is experiencing no torque, isn't it? Only this planet is applying gravitational pull. This way, all the pull is passing through the center. So if you can conserve the angular momentum about this point, you can connect the initial point and final point. That is how you have to connect, right? You know this, you know some of the initial condition, you know its velocity, you know some of the things about the final condition. So if you connect them, you get an equation. And to connect them, you have to use conservation of angular momentum. Is it clear, making sense to everybody? Speak up. Is it clear?
Yes, sir.
Others? अरे बोलो भाई.
Yes, sir.
Yes,
Clear.
sir.
Who else has to say? प्रणव, आया समझ में?
Yes.
Yes. Okay. Fine. So, should I do it or you want to do it? You do it. Get the equations. Complete. You don't need to solve it. Get the equation which will be used to solve, and let me know once you're done. Type in once you're done writing the equations. You have to write 3 equations. Conservation of angular momentum, I'll write mass of the particle, let's say mp v naught into d. Angular momentum about this point. How will you get the perpendicular distance? Perpendicular to velocity, the distance is d. So this should be equal to mass of the particle v into radius of the planet is r. What happened? V into r, v naught, v into r. So v into r should be equal to v naught into d. That is the first equation. Then you have conservation of energy, half mass of the particle v naught square minus g. Is it very far in from dust particle to the planet from great distance? So potential energy initially is 0. This should be equal to half mass of the particle into v square minus of g m mp by r. Now mass of the planet is not given, but escape velocity is given. That is where they want you to use that stuff. So you know that escape velocity is root of 2gm by r, isn't it? So gm by r becomes escape velocity square divided by 2. So this is escape velocity square divided by 2. This is the second, this is the third. Then you have to basically find mass, how much mass of dust particle has been collected. Collected mass, once you get the value of d, is pi d square into L. This is the answer. Okay. Any doubts, anybody? You can speak up. Final answer I don't have for this. But I hope you got the equations, right, Tanay? Tanay? Okay. All right, shall we move ahead?
Yes.
Ready? Five minutes for this. Yeah, rod has mass, bead has mass. Look at the distances carefully. R0 and L and X. R0 is extremely large. Shall I do it?
So 1 minute.
Okay, so let us discuss this one. So, Pranav, how will you do this? How will you start? What is the thought process?
Maybe because the force, there's a very tiny difference in distance across the rod. So maybe that would affect the acceleration of the rod compared to the bead, and we try to figure that out.
That will affect what?
The relative acceleration of the bead and the rod.
So you're basically trying to find relative acceleration of bead and the rod.
Hmm.
That's what you're trying to find. Good. So that is what you have to do. Find out the acceleration of the rod, find out the acceleration of the bead, and then get the relative acceleration. Okay, because they're asking how much time it takes for the bead to come out, right? So bead is moving on the rod, so rod is also moving, so you have to get the relative acceleration. For that, I need to get the force on the rod. So to get force on the rod, you have to consider at a distance of x dx, thickness of the rod, mass per unit length lambda. So the df force is g mass of the earth into lambda dx, mass of the small mass of that, into divided by x square, right? This is df. Integrate this, you'll get the value of force on the rod, right? And force on the rod should be equal to mass, which is lambda into L times acceleration of the rod. So from here you'll get acceleration of the rod. This is clear, right? This will give you acceleration of the rod. Now acceleration There is an approximation probably involved here. So let me do it completely. So Gm lambda, it goes from R0 to R0 plus L. So 1 by R0 minus 1 by R0 plus L. So I'm assuming the force on the rod to be constant. Is it true that it is constant? Because R0 can keep changing, yes or no?
Yeah, so it'll vary as it'll increase as it gets closer, right?
So, but why I'm assuming it to be constant?
Because R0 is much, much larger.
R0 is extremely large. And we are talking about the time in which the bead will come out. That time would be in seconds or minutes or in hours, let us say. But this 4 into 10 power 8 meter, nothing will happen to it. So that is why we are ignoring the variation of the force between that time interval when the bead comes out. So this is Gm R0 L divided by R0 plus L. This is acceleration of the rod. Now acceleration of the bead. Acceleration of the bead is a force we can write directly. G m is the mass of the bead, let us say, divided by R0 plus x0 whole square. This should be equal to m into acceleration of the bead. So acceleration of the bead is Gm divided by R0 plus x0 square. Now x0 is very small compared to R0, so you ignore x0 from here. So it will be Gm divided by R0 square. So this is acceleration of the bead. Right? I'm adding x0 to R0. It doesn't matter. So the relative acceleration is acceleration of the bead minus acceleration of the rod. This is your relative acceleration. And once you get relative acceleration, you know x0 is equal to half a relative t square. So from here you get the value of t. Clear to all of you? So in this question, you have to think in a very simple manner and use approximation to get the answer. And you need to appreciate the distances involved. If you don't acknowledge the fact that distances are very small compared to R0, you'll make it extremely complicated. And some of you might have done that. Right? All of you clear about this? Shall I
Yes.
move? Okay, 5 minutes for that. This one. Okay, so we will discuss. Okay, one answer. Two people got the answer. Who will explain the thought process? Anvi, what do you think? How will you proceed?
So first I tried to draw the diagram.
डायग्राम बनाते हैं, चलो ये रहा डायग्राम. तेरा डायग्राम, it is found, और फिर it has atmosphere, right? ठीक है, बना लिया डायग्राम. Then hello. Am I audible, Anvi?
Oh yes, sir. I was on mute.
हाँ.
After that, I tried to like
Hmm.
I tried to like understand the situation and like write some equations. I wrote the equation with the I wrote the equation of the force. I took like a small volume in the atmosphere.
Okay. So you use the small volume to do what? How will that help you?
It
To get what?
gave me like a proper mass and object, point object, so that I could write my equations easily.
What equations? That's what I'm asking. What are you trying to write? What are you trying to achieve using
I wrote the equation of force due to
force? Correct. So
yeah,
you are writing force equation so that you get acceleration due to gravity.
yeah,
Acceleration due to gravity is total gravitational force divided by mass.
yeah.
So you're trying to find force on that imaginary point mass kept at a distance of x away. All right. Now the force, can you divide into two parts? One from the planet and one from the this thing, atmosphere, right? Now what you can say, see, for the planet it is straightforward, right? The force from the planet, you can directly write g mass of the planet into mass of the particle divided by x square. But how will you consider the force due to the atmosphere? How will you take care of that? Should I ask somebody else? Okay, I have troubled you enough.
So is it only because of the inner part of the atmosphere and not the
Right.
outer?
So you can draw one imaginary spherical shell, and you know the shell theorem? Only the mass that is within this green sphere can apply the force. And it will apply the force as if it is located at the center. So you just need to find how much is this mass, and whatever mass comes here, you can directly write g into gmm by x square. That's all. So mass of this atmosphere which will apply the force, mass of the atmosphere, again, you all know, you have done it enough number of times. 4 pi r square dr, rho into dv, right? Integral. So 4 pi rho integral of r square dr. Integral will go from where to where?
Sir, rho is not constant. Right?
Arey, haan.
Yeah.
Sorry. 4 pi integral rho is sigma naught by r. So 1 by r square dr. So limit will be from where to where?
To X.
From
So R to X
R2.
minus R.
r to x, right? So it'll become 4 pi rho naught becomes x square minus r square by 2. So this will become mass of the atmosphere. So the force, total force is gmm by x square plus g, mass of the atmosphere, which is 2 pi sigma naught x square minus r square m divided by x square. Now gravity g is F by m, so m and m gone. So you can write this as g m by x square minus 2g pi sigma naught by x square into r square. This I'll keep it separate, plus 2 pi sigma naught g. Now this g should be independent of x because it is said that it should be constant throughout. It will be independent of x only when this bracket term is 0. So equate it to 0. Then it becomes, g becomes constant, which is this. Clear to all of you? Speak up, guys. Is it clear?
Yes, sir.
Okay.
Yes, sir, clear. Final answer comes out to be
Final answer. Someone got the answer right. M divided by 2 pi r. Oh, that is your answer only. Same answer Suhani also got.
okay. All right.
Only the part 1. 5 minutes for that. Okay, so shall we discuss? Who is this Hans Seha?
Yes.
Okay. From WebGear, is it?
Yes.
Okay, okay. All right. So who will? Tanay,
Yes, sir.
tell how to start.
Atmospheric pressure is the total force applied on the Earth by the atmosphere divided by the area of the Earth.
Mhm.
And we can find the force applied by the atmosphere on the new planet by the gravitational force.
But what is you're trying to achieve? Ratio of atmospheric pressure on the surface of the planet to the Earth. So given whatever are the scenario, whatever parameters are given here, uh, mean density, mass, mean density. Why do you think mean density is given?
Uh, like average density, so you don't have to, you just multiply it with the volume.
Exactly. Right. Diameter of the planet is given. Its mean density, mass of the atmosphere, d naught, rho naught, and m naught. Okay. Mean density of the atmosphere is same. So atmosphere's density is same. Now suppose atmosphere density is given and the height of the atmosphere is given. What could be the atmospheric pressure then?
You would need to integrate for different points because the gravitational force
No,
will
but
be.
you are assuming density to be constant. Mean density of atmosphere. So that is,
Then you have to multiply with the volume of the atmosphere as well to find the total mass of the atmosphere.
are you sure? Mean density is given, so I can just use rho gh.
Yeah, we can do that as well.
I can directly, I don't need to integrate. That is why, the mean values are given here. So if let us say I have to solve the first question, it should be like uh, mean density of the atmosphere is same, right? So let's say that is sigma naught. Sigma naught, G naught, sigma naught, G1 H1 divided by sigma naught G2 H2. So the answer should be G1 H1 divided by G2 H2. I do not know the value of G1, H1 and H2. So this is, now I will try to find out G1 H1 and G2 H2. All of you agree? Everyone? This is Earth. This is planet. Okay. Now how will you get H1 and H2? What do you think? Everyone? I want
Mass of the atmosphere.
what?
They've given us the mass of the atmosphere.
So how will you do that? It is the mass of the atmosphere of the planet is 10 times the mass of atmosphere of the Earth. So how will you use that?
Volume, because density is constant.
So what should be the equation? What should I write?
So it's given that height of atmosphere is very small compared to radius. So
Hmm.
instead of using the volume of a cube thingy, volume of a sphere, you can just take surface area into height.
What should I
Right.
write here?
So surface area will be 4 pi into r square or pi into d square, where d is the diameter of the planet, times h's height of the atmosphere will be equal to the volume of the atmosphere, and
Okay.
mass by volume is constant for both planets.
Fine. So you can do that. And you can equate the so let's try to do that. So m naught is basically what you are saying is 4 pi radius of the Earth. You have to write 4 pi r square into, this is H2, that into density of the atmosphere sigma naught. This is m naught. Now the 10 m naught should be equal to 4 pi radius of the planet square times h1 into sigma naught. Are you able to understand, everybody, this equation what I am writing here? This is m naught, right? So I'm writing 10 m naught as 10 into that. So this equation, all of you get this equation? Can you type in? I mean, you don't need to do this approximation. What you could have done is sigma naught into 4 pi 3, 4 pi by 3 into r earth plus h2 square, h2 cube minus r earth cube, and then use binomial approximation, you get the same thing. Because h is very small compared to re, so you can use binomial approximation, take re outside. Okay, can you type in, is this equation clear or not? Everybody, is this equation clear? Okay, fine. So radius of planet is how much time of radius of earth? 10 times. So we'll get something here. So we'll get 100 into h1 should be equal to 10 into h2. So h2 is 10 times h1. That is, you get h1 by h2 now. g1 by g2, that is, I guess, easier. Diameter of the planet, mean density is this. So basically, you need to get the value of g in terms of density. This is gm divided by r square. So m is 4 by 3 pi r cube into density divided by r square. The small g is 4g pi r rho by 3. So g1 is, the g1 is for the planet. Density is 4g pi by 3. The radius is 10 times radius of the earth, and the density is rho naught by 4. So 10 by 4 is 5 by 2. So 5 by 2 times of g2, g1, right? So we have g1 by g2, 5 by 2. h1 by h2, 1 by 10. So multiply, multiply, so we'll get 1 by 4. That should be the answer. Clear to everybody? This is not Olympiad, okay? This is, I think, one of those JEE Advanced questions only. The last 2-3 questions were not Olympiad. Is it clear to everybody? Type in. Anybody has any doubts? You can speak up. No doubts? Nothing? I'll move ahead, okay? Five minutes for this. If you do both parts, take 6 to 7 minutes, both parts. Anyone? About to get? Anyone about to get the answer? Okay. How to proceed, Samarth? Samarth is there? You're on mute, Samarth. Samarth is not there. Okay. Shruti, how will you do this?
So for this question, we are talking about a satellite which is pretty close to Earth. And now we are saying that this collides.
Indian accent. Indian accent.
So we are saying that there is a satellite that is hovering over the Earth, and there's a cloud of dust particles that comes into contact with this particular satellite. So because of this, it appears that it experiences some kind of a resistive force which decreases its velocity. And we know that since this is going in a circular orbit, omega cannot change. So if velocity decreases, then something else must make up for it, meaning the radius also decreases, and we proceed from there.
How will you find force?
So I did dm by dt into velocity.
Right. So you might have seen some scenario where you must have encountered some question with bullets are hitting the wall and you have to find the force, or you might have seen scenario where photons are hitting the surface and you need to find the force. So their rate of change of momentum is what you need to find. So and uh, in case of fluids also, you might have seen force. We have to, here mass is changing, right? As it keeps sticking on it, mass is changing, so force is v dm by dt. Force is m dv by dt plus v dm by dt also. Okay. Now velocity is changing very, very slowly, so we are ignoring that. So it is just simply v dm by dt. I hope this is clear to everybody.
Yes, sir.
Encounters.
So I have a doubt here. We said that velocity is changing very slowly, but it's still changing, right? So do we have to write it as a function of mass over here, or we just assume that it's the same velocity throughout?
We're assuming it is same. I mean, it's that variable mass scenario. So we are ignoring that change in velocity. Extremely less.
Sir, but can't we find that velocity if we conserve momentum?
You can do, why not? You can do all that, but you're not supposed to do. We need to all understand that what you're supposed to do, what you're not supposed to do. So sometimes we are running behind highly accurate scenario mathematically unnecessarily. For example, here the mean radius is given. So simply we have to write rho gh, but the first thought that comes in our mind to integrate, then what else? There was this scenario also. Here we ignored x naught compared to r naught. So physics is not about being 100% accurate, because uh, if you complicate it and try to include everything, probably you may not be able to solve the equation itself. Okay, but then we'll talk about change in velocity in the second part anyways. It changes, but it changes extremely small rate, so we are ignoring that. Force is V dm by dt, and dm is what? It is area of cross section. S dx is dv dt into rho. So it is rho s v square. S is a cross section area, which, so basically as it is moving, the dust is sticking on it, and rate at which dust is sticking, that is what is dm by dt. Okay, so this is the force. Now how will you find the velocity? With what velocity it sticks? How will you get? It's the orbital velocity, don't you think so? So it will be gm m by radius of the earth square, that should be equal to m v square by r. So v square is equal to gm by radius of the earth. That will go there and you'll get the value of force. This is your first part. Okay, and it is no longer moving in a circle, its radius shifts continuously, and if dust is there, it will slowly falling in here, right? So basically you can't even use this equation. You can argue that how can you use this equation? This equation is valid only for the circular motion, but it is not perfectly circular. So how will you get the second? How will you solve second part? Any ideas? Anybody? Anybody wants to tell? Second part, how will you do it?
So since torque is zero about the center, do we conserve the angular momentum and try to find the new radius?
Find the change in velocity and the radius of the circular path. But to find the new radius, you need to know the new velocity, isn't it? And do you think angular momentum is conserved? Are you sure? Isn't dust creating that external torque with respect to center?
Can we conserve linear momentum in the collision?
There is a force. The force is only you found. Drag force is there. Right? So if there is an external force, think more, think more. How will you find change in velocity?
So can you find acceleration, like the tangential acceleration, using the drag
How?
force?
So using this, you find the tangential acceleration. This is the force. This force equal to mass into tangential. Then what?
So, and they've said that it's one revolution, so you know the time period for one revolution anyways.
Yes, you can do that ways. Any other way? Then think of anyone. See, there are only two ways to handle. Either you use the force or torque, or you use the energy. Okay. So in conjunction to the momentum conservation cannot completely solve your question until unless something is already given to you. So either in mechanics you'll be using force or energy. So there are always two ways of solving question. You can use energy, but in order to use work-energy theorem, you have to use work done is equal to change in the uh, total energy, right? Now why I'm putting negative total energy. Work done over here, is it positive work done or negative work done in one revolution when it is revolving?
Negative.
It is negative. So work done is minus of rho s v square. Now here also approximation. I'm assuming this force to be unchanged in one revolution. But the fact is, slowly the force is decreasing as it is going in. Oh, sorry, it is increasing because velocity has to probably increase as its radius is decreasing. So, but then we need to keep that approximation, and this is this one, and total energy of a satellite is what? Do you remember? Minus of GMM by 2R. Do you remember this? Kinetic energy plus potential energy is this,
Yes, sir.
right? So this is equal to change in the energy. Now this is E. So delta E is GMM by 2R square into delta R. Because delta R is very small, I can use derivative concept here. So GMM by 2R square delta R. This will give you delta R. Delta R is negative because it is coming in. So delta R is negative.
So won't delta E be caused by change in velocity also?
Yes, it does.
So why aren't you?
Velocity is a function of R. Velocity is a function of R. So this is kinetic energy plus potential energy, sum of both.
Okay, so
See, let me complete. See, this is the delta E. Once you know delta E, let's say you got the value of delta R using this, what you can do next is this. This same delta E, same E, you can also write in terms of the kinetic energy, which is minus of half m into v square. Do you remember this? It looks like some of you have forgotten that. So I hope you know that gmm by r square is equal to mv square by r. So r get cancelled. So half mv square is equal to gmm by 2r. Now you remember this? Suhani?
yes, sir.
Right? So total energy is minus gmm by 2r, total energy of the satellite system. So delta E once you get, that is also equal to negative of E is equal to negative of half mv square. So delta E in terms of velocity also you can write, which is m2v delta V. So in terms of velocity, it is minus of mv delta V. So if you get delta R, you can relate it to delta V. Equate these two. Is it clear? Clear to all of you? Everyone type in. See, it is the change is so little that we are assuming it is going in a circular path. And change is so little that in one revolution, delta R is like dr, extremely less. So that is why all of these approximations are used here to get the solution. All of you, is it clear? See, I have chosen questions which are not regular types so that you can see what all things can happen in gravitation chapter. Okay. So if you're not getting most of it or anything, that is good. You're learning something new. You are utilizing your time properly because every second, every minute you're learning something new. That is what counts. Okay. Solving number of questions which you can do in first attempt is a waste of time. Now do this. These are not Olympiads, okay? They are like proper JEE Advanced questions. But there is a twist in the tail.
So I didn't understand what we have to prove.
You have to basically get a relation between small n and rest of the thing. That's all. How the
No,
variables are connected.
no, like that last point,
Hmm.
remain above the same point on the equator. What same point?
See, same point meaning that it is revolving with the same angular velocity with the Earth. Okay. Relative to Earth, it is, it is revolving with the Earth. Is it clear to everybody?
Got it, sir.
It's like a geostationary satellite type of thing. See, again, it is a circular motion. So just find the force towards the center. And
is NR from the surface or from the center of the Earth?
is it not clear? Just above the surface of the Earth out to a radius NR. NR is the radius, center. Whenever something is moving in a circle, just write net force toward the center is m omega square r. That's all is there in this question, most probably. The elevator is not touching the earth, okay? It is written that elevator is just above the surface of the earth. So there is no question of normal reaction. Anybody is getting? Okay, Pranav got the answer.
Yes.
Anybody else got the answer?
No, sir.
Okay, fine. So this is the Earth. This is the rod. It's rotating with omega naught. So even the rod has to rotate with omega naught, and the rod is not touching the Earth. Average density is rho proposed to mega space elevator. Out the radius nr. This is nr. This is r. So the this is the center of the rod, right? So first we need to find the force towards the center. So this is like a rigid body rotating in a circular path. So we just need to bother about the what happens to the center of mass of the rod. Center of mass is moving in a circle of this radius, right? So this radius is how much? This radius is, this is nr, this distance is nr minus r divided by 2. Total length is nr minus r, that is nr minus r divided by 2, and add r to it, that is the distance of the center of mass, from the center of the revolution. So that is nr plus r by 2. So this is the radius. Then we have to find the net force. So this is like, let's say at a distance of x, this is dx. Something similar we did. So F is g m lambda x dx divided by x square. And then x goes from r to nr minus r. So this is g m lambda one
So
minus.
shouldn't it go to NR? We're measuring x from the center of the earth, right?
Ah, correct. Correct. R to nr, right? Gm by lambda 1 by r minus 1 by nr. F is equal to Gm. The lambda can be written as lambda is total mass divided by length, which is nr minus r. This should be equal to m. M is m omega square into the radius of revolution. This is the equation. You just cancel out the unnecessary terms, simplify, you'll get the answer. We have not done anything great here. Just found the force, found the radius of revolution, and wrote the centripetal force is equal to m omega square r. That's all. Clear to all of you? Any doubts, anybody? Nothing. I'm going to next question. To this. 5 to 6 minutes. Both the parts, 6 to 7 minutes. Do you guys get breaks during the crash course?
No, sir.
We'll discuss in couple of minutes. Let's get one hint. How will you relate maximum distance? What concept to be used here?
Energy conservation.
Energy conservation. How will you identify the point which is having the maximum distance from the center? What is that identification?
I will not say that the entirety of the kinetic energy gets converted to potential energy at that particular point.
No, need not be. It will still have some velocity.
The point at which relative velocity with the center becomes zero.
No, but somewhat like that.
In the direction of the center, rather, so that it's not going further away and now it's coming closer.
Correct. It is the velocity component.
That's what I meant. Component. Sorry.
Component away from away along the line joining is zero. It will keep on going away, and then the velocity become perpendicular to the line joining, entire velocity, right? Now think over it. Which concept will you use to relate that point with whatever point you know initially?
Sir, SHM.
No, it's not SHM. It comes out of the tunnel, right? It goes out. It is moving outside.
At that specific point, it's in circular motion at that instant because velocity is perpendicular to the center.
So is it conservation of angular momentum?
Angular momentum. So these are, I mean, you should be now tuning your thoughts that whenever you get such scenario, you have to use conservation of angular momentum, because that is where, I mean, we used to think that angular momentum is like not so useful and not so fundamental e- equation. It's just like mathematical correlation with velocity and perpendicular distance. But we forget to use it like how we use conservation of linear momentum. Start using it. Whenever you see that about a point, about any point, let us say torque is zero, you can use the conservation of angular momentum. For example, here, once it comes out, first of all, once the particle is inside, there is a normal reaction also. Let's say if it is here, there is a normal reaction which will have torque about the center. So that is why angular momentum is not conserved. Oh, angular momentum is written also, right? So you need to get the hint from here itself. Anyways, once it comes out like this, then normal reaction becomes zero. Now angular momentum is conserved because only other force is gravitational force, which is passing through the center. So about the center, torque is zero. So it goes like this and like that, right? No, it will come back. Sorry. Goes like this and tries to again come back and fall maybe. Okay. So maximum distance appears to be somewhere here. It is here, where the velocity is making 90° with the line joining. All right. So between this point number 2 and point number 1, you can conserve the angular momentum. Okay. Right. But you need to first get this velocity. This is V1, this is V2. How will you get V1 and V2? Right now it is at a distance of r/2 away. So you need to get only this much part of the earth is creating the force. Oh, it will be that formula. Do you know the potential, gravitation potential inside the solid sphere? Anybody remembers that expression? Inside the solid?
GMM by 2r cube into 3r square minus small r square.
By 2r cube into 3 small r square.
No, capital R square minus small r square.
This is correct?
And minus sign, like overall.
This is minus. Okay, great. So basically, first step is to get V1. So between this point, this is point O and 1, we'll use conservation of mechanical energy. Why it will not perform SHM? So suppose it is restricted inside the funnel, then it will perform SHM. But suppose at point number 1, suppose you use conservation of mechanical energy, okay? And you're getting velocity at point number 1 to be 0. Then the maximum distance is this distance only. Oh, sorry, that distance from the center they're asking, that is r only. That is the answer. But suppose you're getting greater than 0 velocity, it means it will come out. So you need to check whether it will be confined within or not. So let's not assume anything. Let's find V1. So you substitute small r equal to r by 2 here. Potential energy is mass into potential. So that is your U0. So U0 plus half m V0 square. V0 is given. That should be equal to U1. U1 you can write very easily. GMM minus of GMM. Minus of GMM by R plus half m into V1 square. Now, most probably V1 will come out to be greater than 0. It is a JEE Advanced question. It can't be just this much. So V1 is greater than 0. Now, once you get V1, then you need to do one more circus here. Because this, about that point, perpendicular distance is not r, right? Of this velocity, perpendicular distance from this point, line of velocity, is r by 2. Okay, theta and all will not come. So angular momentum of that V1 at point number 1 is mv1 into r by 2. That should be equal to mv2 into this distance d. So m and m get cancelled. This is your first equation. Now you have to do conservation of mechanical energy between 1 and 2. So minus of gmm by r plus half mv1 square should be equal to minus of gmm by d plus half mv2 square. So solve the 1 and 2 equation to get the value of d. This is how you do it.
Sir, in the first part of the question, they asked if angular momentum is conserved in the tunnel, right? So since at both the middle point and at the end point, the perpendicular distance remains same from the center. So wouldn't the velocity be same if angular momentum is conserved?
Angular momentum is not conserved as it is inside the tunnel because there's a normal reaction also applied. That normal reaction, torque is not 0 about point O.
Yes, sir.
Once it is outside of the tunnel, then only the force is passing through the center of the earth. So you can say that outside of the tunnel, angular momentum is conserved. Inside the tunnel, normal reaction is there, angular momentum is not conserved. But then yes, if it would have been conserved, then velocity will not change. You're correct to point out that.
So, but the particle inside the tunnel doesn't necessarily have to touch the tunnel, right, for the normal reaction to act.
Normal reaction is a contact force. You need a contact.
Okay.
And it will touch. It has to touch. It can't. I mean, when you give the velocity, projectile is fired along a tunnel from the center. That velocity, how will you give? Suppose you are like, okay, no, I'll give the velocity if it is inside the tunnel in the air. I'll give, so it becomes a projectile, and you'll say that it will come out before it falls on the ground. But tunnel distance is r/2 given. So you need to assume that tunnel is very, very thin. So you, even if you move little bit in vertical direction, you will touch. So you can't ignore the contact.
Okay.
This is like one of those regular straightforward questions. This one. How much is the time? Okay. You have 6 to 7 minutes. This is, whatever question I'm giving now, it is pretty much doable. Please attempt it with full energy. Don't put your energy down. Done?
Yes, sir.
Is this a regular thing where 20 people join and at the end 13 left?
So this is a good thing actually, because normally there are about 6 people left by the time the class gets over.
Oh.
So this only happened for like the last physics class and this one.
Physics actually, JEE Main Physics is easiest of the 3 subjects, but JEE Advanced Physics is toughest of all 3. Physics changes colors very fast. So, but then the basic theme remains the same. If you think in a simple manner, mathematics can be tough, but if your thought process is simple and straightforward, you'll be able to crack. Don't complicate your thought process. That some random theorem you know or some expression you remember. JEE Advanced is not about knowing 100 things. It's about just knowing few things and able to use them. But don't run behind new theorems, new equations and all that. It is all useless. Okay, so shall we do it? Anybody about to get the answer? Do we have more questions? Too simple. I think that's it. This is after that we have just straightforward questions. This is also not tough, but I don't know why you are not doing it. Anyways, shall I do it? Somebody did, is it? No. Okay, Vittal got something. Okay, yeah. Seems to be correct. Vittal got it. Aditya got it. Let's see. Anything moving in a circle. What did I tell you? Force toward the center is mv square by r or m omega square r. So let's see that. Particle of mass m moves under the action of central force. Whose potential is this? If this is the potential, the field is what? Gravitational field. Do you remember this? याद है?
Yes, sir.
Yes, sir.
Gravitational field is minus of 3k r square. Now, just like charge into electrical field is electrical force, mass into gravitational field is gravitational force. So, the force, gravitational force is 3 mk r square. I'm ignoring the negative sign, just as the direction. This should be equal to m v square by r. For what energy? Okay. So mv square is equal to 3 mk r cube. So kinetic energy is 3 by 2 mk r cube. This is kinetic energy. What about potential energy? How do you find potential energy? Anyone?
Mass into potential.
Mass into potential. Just like mass into electrical potential is electrical potential energy, mass into gravitational potential is gravitational potential energy. So minus of mkr cube. So total energy is sum of these two. So which is 1 by 2 mk r cube. Now put r equal to a, you'll get the answer for the total energy. And the angular momentum is mvr, right? M into v into r. Now how will you get velocity? So from here, get the velocity in terms of r, substitute here, you'll get angular momentum. And then period also, you'll get 2 pi r by v. Again, v you can get from here. Clear to everyone? This is a proper JEE Advanced question. This is how it will be. It can't be easier than this. Fine. Let me see what else I have. This question, though, you might have seen so many times, should not even bother to. Half the magnitude. Nothing. Did I leave anything? Oh, above? No. Chalo, ठीक है. Just for completeness, we'll do these questions also. Solve to get the correct answer and quickly. So I think you all are able to do this after doing some tricky ones. Artificial satellite is moving in a circular orbit around the Earth with a speed equal to half the magnitude of the escape velocity. Okay. This is the escape velocity. Half of it is this. This is the velocity. Determine the height. So mv square by r. Height you have to determine, not the radius. So r is gm by v square. So Gm by V square is 1 by 4 2 Gm by R. So it is 2R. 2R, no? So height is R. 2R minus R. Okay, if it is an MCQ, there will be an option of 2R also. So if you are in a hurry, you will mark 2R and move ahead. There go your 1000 to 2000 ranks. Okay, so be very careful in JEE Advanced. It's not about speed. JEE Advanced don't hurry up things. If a satellite stops suddenly in its orbit and allowed to fall freely, speed at which it hits the surface of the Earth, it stops. So velocity becomes 0. It has a potential energy. So I hope you can do all of this. I don't need to do it. That's it, I guess. Right? So we'll end the class here. And anybody has any doubts in gravitation from anywhere? Anything? You can ask now. Nothing? Okay.
No, sir, no doubts.
Take care of your chemistry, guys. I have seen chemistry percentiles of yours are not great. And remember, the rankers, their chemistry is the best. So, learn chemistry. Forget about, it's boring and all that. Don't make such excuses. It's not about boring or something. It's about your future. It's about your ranks. So, attempt chemistry properly and learn. There is a time that you can learn. You can basically see what all tricky things you don't understand of chemistry and learn them. Okay. Chalo, bye.
Thank you, sir.
Thank you, sir. Bye.